We've all been there. You're deep into a complex project with an AI, and suddenly it forgets the very first rule you gave it. It feels like the AI has the memory of a goldfish, but this isn't just a glitch, it's a physical limit of how large language models are built. For years, the context window was a hard wall. If you went over it, the oldest data was simply deleted. But in the last few months, everything changed. We've entered the era of persistent AI. Today, we're breaking down the breakthroughs that allow AI to remember 50 times more while using 8 times less power. Let's dive in. To understand the fix, you have to understand the bottleneck, the KV cache. Unlike you, an LLM doesn't actually learn while you talk to it. Instead, it creates mathematical snapshots of every word. These are called keys and values, and they are stored in your GPU's expensive memory. The problem, this memory grows linearly. If your conversation doubles in length, the memory it occupies doubles too. This is why long context AI is slow and why high-end chips like the H100 are in such high demand. We were hitting a ceiling where AI simply couldn't handle more data without crashing the hardware. The first major breakthrough came from researchers at MIT and NVIDIA. They realized that not every word in a 10,000-word chat is actually important. This is called attention matching. Instead of saving every single word, the system now uses algebraic approximations to find the heavy hitters. These are the tokens that carry the most meaning, and the system discards the fluff in real time. This leads to a staggering 50x reduction in cache size. It's a game changer for memory efficiency. Simultaneously, NVIDIA's dynamic memory sparsification introduced active forgetting. It allows the AI to delete its rough drafts or temporary thoughts as it works through a problem. By only keeping the core logic, we get an 8x boost in reasoning speed. The AI is finally learning to take notes instead of memorizing the whole book. This brings us to section 4. But what if we change the architecture entirely? Enter state space models, or SSMs. Standard transformers use global attention, where every word has to look at every other word. It's a mess. SSMs change the math. They act like a rolling summary tape that stays efficient regardless of length. Whether you are at token 100 or token 1,000,000, the memory footprint stays exactly the same. We are seeing models now that can ingest entire codebases or 24-hour video files without breaking a sweat. It's no longer about a window of memory, it's about a constant stream of consciousness. The final piece of the puzzle is TurboQuant. This is Google's breakthrough for on-device AI. By using high-speed compression algorithms, they've managed to shrink the memory footprint by 6x. This is huge for privacy. It means your AI can remember your personal details entirely on your phone. It knows your family's birthdays and your work history, no cloud required. A personal assistant in your pocket. We are moving from chatbots in the sky to personal assistants that actually know who you are. Memory was the last great barrier for AI. Now that we've solved the goldfish problem, everything changes. AI is transforming from a search engine into a true collaborator, one that grows with you every day. Which of these breakthroughs do you think will change your workflow the most? The 50x compression or the move to on-device privacy? Let me know in the comments. Thanks for watching, and I'll see you in the next one.